Okay, so this is going to be 3.6. This is our last section of chapter 3 that we're going to go over, and we're going to talk about solving trigonometric equations with a little bit of a twist here where we're going to have multiple answers as we go. All right, so first of all, a trigonometric equation, just to give you some terms here, is an equation that contains a trigonometric expression with a variable, such as sine of x. Identities, which we went over, are like this, right? That's our Pythagorean identity we'd like you to know. Solutions are values that satisfy the equation. We will begin going from 0 to pi and then expand it to all of them. So we know that trig functions are cyclical, so there's an infinite number of answers. The most typical answers we're interested in are from 0 to pi. So if we look at this, do you remember what the sine curve looks like? If you remember, it starts here at 0, right? Halfway it's back to 0. At the end it's at 0. And it heads up to 1 at the first quarter. This is our 5-point method. This is what I would get, right? And then if I extend that back a little farther here, right, it does the same pattern back this way, sort of up to here, and so on, okay? And it would go on and on and on forever. Now, if we solve this by graphing, where is sine of theta equal to 1/2? So that would be right here on this line, okay? It would be right there. So where do these values occur then, right? So there would be one here, there would be one here, there would be one here, and there would be one here as we go. So if we look at the 0 to 2 pi, right, they're right here, and you could use your unit circle to pick these up. I'm not sure if you can put it together in your head yet, but I'm trying to find out. It has infinite number of solutions, but if we look at the 2 there, that's going to occur at pi over 6, if you remember, and 5 pi over 6. And then what we could do is extend this by 2 pi along that way and this way, and extend this by 2 pi that way and that way. But those would be the two bases for the questions where I'd have to find these two because they are not related that way. All right, so let's look at number 2. Number 2 requires an ounce of solving. So to do it again, what we could do here is we could add 1. So I would get cosine x equals 1. And then divide by 2, and again, we're going to stick to questions that hopefully produce an answer that you're familiar with. So now I have cosine x equals positive 1/2. So the thing here that it's not being focused on so much is that this is a positive, right? So I guess I won't put anything there, but that's what you get. Oh, sorry. That's what you get for that. So where is cosine positive? It's in the first quadrant, okay? And the idea would be here, if we just sketch it out this way, and here, right? And it's a half. So first and fourth quadrant, okay? And what would these 2 degrees be if I did it this way, right? That would be 60 degrees and 300 degrees. So that would be one answer. Just to rehearse and remind you, radians, anybody remember what this would be? This could also be written as pi over 3, right? Because 180 divided by 3. And then down here, probably the easiest way to get this if you took 6 pi over 3. Remember doing that? And subtract a pi over 5, that would be 5 pi over 3. So if we're doing radian measures, these would be your 2 answers. But hopefully if we solved that, we could look at a unit circle and saying, where is it equal to 1/2, identify the quadrants, and come up with it. So we did the 5-point method, we did it on the circle. All right, let's look here then at number 3, okay? Number 3, it says collecting like terms. So if I did this, let's get all of those on one side. So I would get sine of x. I'm going to take this over and move this back over. So I'm going to add sine of x to this side, and I'm going to subtract root 2 to that side. All right, so what happens here if I combine like terms? I have 2 sine of x, you see that? Equals negative root 2. If I divide both sides by 2, again, we're going to stick to things that produce hopefully something we can recognize. I get to that. Now, where would that occur? All right, if we kind of use the unit circle idea for this one, because it's a little simpler. Root 2 over 2, I don't know if you remember, those are the pi over 4s, 45 degrees. Where is sine negative? Sine is negative down here and down here on the bottom half. So there and there. So if we were trying to wrap around here, right, and I know I'm dealing with pi's over 4s, right? Do you agree this would be 4 pi over 4? That would be a pi. And over here, this would be 8 pi over 4. And if this is the reference angles are pi over 4, can you see that this right here would give you 5 pi over 4? Okay, and then this one over here, depending on how you want to come around, would give you 7 pi over 4. Probably the easiest way to do it would be to back this off by pi over 4. So again, we'd like you to be able to put things together, look at them, and solve them. Again, we should get something that we know. All right, now down here, we're going to look at things that would produce more than 2 answers, because when we have a square root involved, there's a chance that we get 4 answers. So let's look at this. Okay, so if I take and add 1 to this, because I'm going to try to get this solved. Okay, if I add 1, do you agree I'd get that? Okay, so I took that over. Then I'm going to divide by 4, so I get sine squared of x equals 1/4. Before I go any further, I'm going to take the square root. Now here's where some algebra comes back in. When you take the square root, do you remember that's plus or minus? When you take a square root, you can take the square root of the top, which would be 1, plus or minus out here, and say square root of 1 is going to be half. So this is all the places, plus or minus a half, all the places where sine would equal a half. So let's try to think where that would be, right? So if you look at it kind of this way again, all right, where would sine be equal to half? That's where the short side, right, is on the vertical side, would be all 4 of these, if that's making sense. So if we had that set up, again, it's a 30-degree angle, so it's pi over 6. You agree this would be pi over 6. This one over here, right, this would be 6 pi over 6 there, so making this 5 pi over 6 is an answer. So we have those two. This one down here would be 7 pi over 6 because of the plus or minus. And lastly over here, if you understand, this is 12 pi over 6 all the way around. Subtract one of them. Hopefully you remember that a little bit before, 11 pi over 6. So this one has 4 answers because of the plus or minus that's involved for that one. Okay, now the last one I want to do here has a little bit of factoring, so let's see if we can do it. So if you were given this, it's already set sort of equal to 0. There are no numbers to take the other side, and I don't want to complicate things by moving trig functions to the other side. So what could you do to it? If you go back to sort of your Algebra 1, do you see the common factor? This is a common advanced math tool to see where it takes me. I'm going to pull out a sine x. If I pull out a sine x, what I get is I get 2 cosine x minus 1. Can you picture that, right? Because you divide both by sine. Remember, it doesn't cancel all the way. This becomes 1. All right, now, this becomes one of those rules where the product rule, right, the 0 product property, which means either this has to be 0, or this has to be 0, or both. Okay, so this one creates 2 problems. So the first one is, I want to find out everywhere where sine of x is equal to 0. And for the other one, I want to find out everywhere where 2 cosine x minus 1 equals 0. So this one, I'm going to do my algebra. I'm going to add 1, divide by 2. You see that would be cosine x equals 1/2 if I'd solve it. So let's see if we can come up with these. Where does this equal 0? Well, if I look here, right, it's where the y's are 0. So here and here, you can call them 2 different things. I'm going to go with 0 and pi are 2 answers we would get for that. Okay, so there's 2 answers that work. Now, again, where is cosine equal to 1/2? Positive 1/2. So cosine being positive 1/2 is over here again. It's there and there, right, where the short side is there, first and fourth quadrant. And again, this right here would be pi's over 6's. Oh, I'm sorry. I did that backwards. Let me do it again. Sorry. So if we have this around here like this, where is sine equal to 1/2? Okay. Oh, cosine equal. What do I keep doing? Cosine equal to 1/2. Sorry. Cosine's equal to 1/2. It makes it like this. Yeah, steeper. So 60 degrees, 60 degrees. Sorry about that. So in that case, right, we have pi's over 3. So if you remember, this is pi over 3 up here. This down here would be 1 pi over 3 short of 6 pi over 3, and you get that. So I would get 4 answers for this from 0 to 2 pi produced by 2 different things, right? When I get the product here, this would produce 2, and this would produce 2. All right, so we'll continue with some examples then tomorrow, but that's your prep